Welcome to Mission Control Houston, and we have a special guest, as mentioned earlier, Mario Runco, a veteran of three space shuttle missions to orbit, and he has a lot of experience in Earth observations. As a matter of fact, he was one of the principals in designing and getting the Window Observational Research Facility up to the International Space Station, which utilizes a special optical quality window to allow the very best photography of the Earth below by astronauts aboard the orbiting outpost. Welcome, Mario.
Well, thank you, Kyle. Appreciate it. Glad to be here.
Great to have you here too. And tell us a little bit about yourself and your space flights.
Well, as you mentioned, I did three back in the 90s, mid 91 through 96 on the space shuttle. And that was when I was involved with the space flights there. That was the start of my passion for Earth observation and utilizing the space platform for studying the Earth.
And we had a picture of you, and it was a little hard to find pictures of you all by yourself because apparently you were the guy behind the camera most of the time.
Yes, sir. I was a shutterbug on board, trying to document not only what we did on board, but also uh, the out the window views, which were spectacular to say the least.
Well, so tell us, I know you brought some of your favorite beauty shots. Tell us a little bit
Okay.
about Earth observations from on orbit.
Well, it'd be a pleasure. Well, firstly, when you get up on orbit, and you get your first view outside the window, it is strikingly beautiful, breathtaking. The adjectives and the superlatives could not describe the feeling and sense of beauty that you get. I have one image of what we see very commonly on orbit, and that's of a sunset. And one of the things about sunsets, and you may not think of astronauts being in the space business and being very technical as being romantic, but on board, whenever there's a sunrise or a sunset, the call goes out on board, and somebody yells sunrise or sunset, and everybody kind of, when they have the opportunity, drops what they're doing, and for the few moments runs up to the window or floats up to the window and watches the sunset, and it is spectacularly beautiful. The good news is we can see that. 16 times every day as we orbit the Earth every 90 minutes. So and it is really spectacular as you might have seen in the image there. And there's some other places on the planet that also jump out at you if you go to a Google Earth map or something like that and just kind of look at the Western Hemisphere. You'll see in the Western Atlantic, east off the east coast of the U.S. in the Bahamas, you'll see this bright turquoise spot. And if you get in a close-up, which we have here for the viewers here, there's a place called Tongue of the Ocean, and my being an oceanographer, this is a very not only strikingly beautiful place, but it's a place to study and has a lot of interesting features. You can see the dark blue area. It looks obviously like a giant tongue, and hence the name. But that is very deep water. And just to the south, below the bottom of the tongue, you see some sand dunes there, and that's very shallow water. And you can see the ripples caused by the waves in the sand at the bottom of the ocean, even from space. And that's Andros Islands off to the west. Again, just the deep blues and the turquoises there are spectacular.
Really beautiful. And then, so tell us a little bit about the activities that go on aboard the space station.
Okay. Well, on the space station, we do have the cupola windows and we have the Destiny Module laboratory window. They're optical quality. The lab window has the scratch pane removed, so we can do science and remote sensing. And there is as you mentioned earlier, the Window Observational Research Facility, into which we put remote sensing and photographic equipment that can be operated either by the crew or from the ground. In the case like we see here, Chris Hadfield installing our latest payload called iServe, which is a payload designed to monitor disaster areas around the planet, whether they be from tornadoes, as it happened in Moore, Oklahoma, or tsunamis, hurricanes, whatever the case may be, and the ability of the camera to frequently overfly the same place many times is an advantage that the space station has that many of our Earth observation satellites do not have, because most of them are sun synchronous orbit and they pass over once every 16 days. So as things change, we can indeed get many updates in imagery, provided the cloud cover is available.
And that's a
Is
joint
not
activity
in the
between
pools.
NASA and the USAID,
Right.
or USAID agency that tracks these kinds of disasters around the world.
And they put in requests to the payload folks, and then they train the camera to take the image. In this case, the iServe instrument is a 9-inch telescope, and it's a little unusual, and it's about as large as we can put into the WRF-RAC, the abbreviation for Window Observational Research Facility. And but we had to do something a little bit different. And most telescopes, reflecting telescopes, which this one is, has the secondary mirror that bounces the light that comes off of the mirror to the eyepiece. Well, that's removed, and the camera is actually on the front end of the telescope. It blocks a little bit of the field of view, as does the secondary mirror, but it allows for a wider footprint. Uh, so if you're not exactly precise on your pointing, you can still acquire the place on the ground that you're trying to image.
Okay.
Yeah,
Well, you've got some more images. Tell us about
yeah.
these.
Okay, the next image up is an image from our Isaac payload, which is International Space Station Agricultural Camera. This was a multispectral camera. It had 3 bands: green, red, and infrared. And you see here the image, the red area on the image is the area that the Isaac camera took, and it is overlaid on a Landsat thematic mapper visible image. And what is interesting about when you do multispectral, in this case, the green, red, and near infrared, if you do a combination of uh, the bands, you get a false color composite, as you have here. And what is striking is it brings up the vegetation, shows up in red rather than green, but then it is very sensitive to differences in vegetation. So you can monitor the health of forests, of crops, and one of the things here, this is Port Charlotte, Florida, and you can see some, right toward the center of the picture, you can see some brighter red areas of a different shade. And that's the ability of the camera to discern the difference in vegetation and the health of the vegetation. In that case, those brighter red areas are actually golf courses. So they're much more they're wet, they're greener, and so I use this image as an example that shows when a plant is either very healthy or stressed. You can detect that from the space platform.
And so farmers around the country are able to use these images to help check on how their crops are doing if they're tied into the system.
Right, and they were through the Space Operations Center at the University of North Dakota, the where from where the Isaac camera came, and this camera actually they were taking images, and what where in the short growing season in the upper Midwest is very critical that nothing goes wrong. Otherwise, the crop is lost, and then of course profit and livelihood. So they use the images to monitor the crops. That if they have an issue in the field, they can go to that particular spot in their field, and it has the resolution to do that. And what you can do is, let's say there's a fungal infection in a root crop like sugar beets, they can go out and then diagnose the problem in the area, buy the fungicide, and address the problem. The benefit environmentally is that I can target specifically the area, rather than in the past where practices were that you'd have to do the entire field or the entire acreage rather than the area of concern. So
And I would
that was a
imagine that
plus.
also helps to keep that kind of a problem from spreading to other farms and
Exactly,
crops.
exactly. It's a win-win. It saves the farmer money. He doesn't have to spend as much on the in this case fungicide, for example, and he doesn't have to spread as much around the environment. Which then, once it's in the environment, it goes into the water table and the streams and all of that. So again, it's an advance in technology that really helps day-to-day work around the planet, and in this case, raising our food crop.
And theoretically, lower prices at the grocery store if you don't have
Yes,
to spend that much money taking care of your
exactly,
crops.
exactly. So it all goes and actually the farmers are pretty. I mean, technologically they are. I had learned in dealing with them that they are pretty savvy technologically. They stay at the leading edge because it behooves them to do so.
All right. Now, I think we probably have time for one more image, Mario. Let's take a look at the next one that you had.
Okay, this one is from our iServe payload, and this one is happens to be of the Grand Canyon. You can see it running right down the center of the photograph, and this is the Colorado River, of course, running through the Grand Canyon in Arizona. And this is an example of what sort of the iServe payload can do. It would narrow in and zoom in on a particular area, and let's say the Colorado River were flooding, and it would overspill its banks. Of course, not at the Grand Canyon. That would be a big flood, but yeah, this is just an example, but you would be able to see the extent of where the flooding had occurred and manage and then help area responders with that information to manage and address the situation locally. So it is designed to help with disaster assistance primarily.
Well, Mario Renko, thank you so much for joining us today. And you have a really interesting background from the Bronx, and you're a former police officer,
Yes,
oceanographer, and all that. And I want to let everybody know that you also went to Rutgers in New Jersey,
yes, sir.
and we have a distance learning network event coming up a little bit later on today at 11:05 a.m. Central Time. And Mario Renko is going to be talking with students at a school in New Jersey at that time. So we'll look forward to continuing on our discussions with you later today, Mario. And thanks
Thank
for
you.
coming and talking to us about crew Earth observations from the International Space Station.
Appreciate it, Kyle. Thank you.